Okay. Welcome. I'm very pleased to start this session 8 of the Applied Urban Modeling Symposium. I'm Ying-Jin. On behalf of the Scientific Committee and all the conveners, I would like to welcome you to this session. And this session, we talk about one crucially important thing, which is the economics in cities. And for this, what I like to do is to hand over to our session chair, Tianren Yang, who is a co-convener of the symposium, to introduce the session. And Tianren is a research associate at the Martin Center of Architecture and Urban Studies in Cambridge. Tianren.
Thank you, Ying. Good afternoon for those in the UK and good morning for those in North America. And welcome to the 8th session of the AUM Symposium 2020. My name is Tianren Yang, and as Ying said, I'm now working with him at the Martin Center at Cambridge. And today I will help to chair this session, The Economics of Cities. Today we're actually very delighted to have two economists to join us and share their latest findings. Both of them are indeed well known in the fields of urban and regional economics. Our first speaker will be Geoffrey Hewings, who is Director Emeritus of the Regional Economics Applications Laboratory, actually known as REAL, at the University of Illinois at the Urbana-Champaign. He is also an emeritus professor in a number of departments at UIUC, including economics, urban and regional planning, and geography, just to name a few. Jeff, would you like to show up and say a few more words to the audience about yourself?
Thank you very much, Tianren, and thank you, Ying, for the invitation to participate. And it's a real pleasure to be able to be sharing this time with Alex and us. The Regional Economics Applications Lab, which is probably the thing that I've devoted most of my academic career to, at least the last 30 plus years, was formed in large part to assist with policy making. And what we had found, colleagues at the Federal Reserve Bank and I, that a lot of times decisions were being made without reference to any analysis. And it was based on how people felt or what they thought would happen. And so part of the motivation for forming the lab was to try to provide some quantitative inputs into that decision-making process without getting involved in promoting particular policies or the other. And the one very nice spillover effect was this: a lot of the projects ended up getting funded, and the students had a chance to deal not only with the development of academic rents from their research in terms of publications, but also have an opportunity of practicing how to talk to public policy decision makers. And what most of them finally concluded that was probably the hardest thing they had to do. Defending their dissertation, giving papers at professional meetings was much, much easier by contrast. And I think that's one thing that I think we really need to make sure that we do as our models become more sophisticated, that we do take the time to translate them into a language that our policy folks can understand. Thank you.
Thanks, Jeff. And our second speaker is Professor Alex Annas. He is the department chair and professor of economics at the State University of New York at Buffalo. He is interested in the development of computable models based on microeconomics theory. And he is also interested in empirically analyze the impacts of changes and policies on urban structure based on these models. Alex, would you like to say hi to the audience and also introduce yourself and your work? You are muted.
Hello, everyone. I'm delighted to be here. I've been coming to AUM for many years. I think I missed the last one for reasons I don't remember. It was a conflict of some sort. So I'm happy to be back, and I enjoyed some of the presentations I could watch. So as Tianren explained, I'm an urban modeler. I use economic theory in my models, trying to always do a little better. So I will be talking about the model I developed for the Paris region, which just got completed as a paper, should be submitted for publication soon. This was the longest paper I've ever worked on. It took 5 years to finish the job, because we did so many things and have so many other things sitting on the sidelines that we can't put in the paper because it would make it really long. And so we're delighted to be presenting. I think my co-author won't be able to attend. I asked him if he could, but he didn't respond. It was only a day ago because I know he's very busy. So the paper is available on my website, and I think the link is there. So there you can also find all the previous papers with the Relutran model. And I would be delighted to have comments from anyone who would like to write to me after the today's presentation and discussion, or during, whatever. There's always so many more things to do that I have a long list of little things I can work on. I know I won't be able to do all of them, but that's okay. So I don't know what more to say. I've been doing this kind of stuff for a very long time, and I'm trying to always do a little better. It won't take much more of your time. Thank you.
Thank you very much, Alex. And as usual, we also have a discussant for this session. And for those who have already attended our previous sessions, you may have already get familiar with Michael Wegener. Professor Wegener is currently a partner at Spiekermann and Wegener Urban and Regional Research. He also serves on the scientific committee of the AUM Symposia. Michael, would you like to show up and say a few words?
Thank you, Tianren. I'm happy to be invited here, and even though I would have preferred to travel to Cambridge in person, which unfortunately was not possible now, but I think we have found, thanks to Ying and his colleagues, to do the same over the internet. I'm very pleased to be invited as a non-economist to discuss the two presentations which we will have here. Due to the generosity of both speakers, I had a chance to look at both presentations in draft form, and what I did yesterday over the weekend was to really prepare short notes which I will use in my comments later. And that, of course, is a great privilege. Thank you very much.
Thank you, Michael. We look forward to your comments. And while Geoffrey is preparing to share his screen, so I would briefly introduce about the timeline of this session. So basically, the session will be divided into two parts, and Jeff will lead the first part to present about 25 to 30 minutes. And then this will be followed by around 25 to 30 minutes about the comments and the questions from the audience and Michael. The presentation title of Jeff is Unraveling the Internal Complexity of a Metropolitan Economy. Jeff, the floor is yours.
Thank you very much indeed. What I want to do in the time I have available is just sample from three of many projects we have conducted over the last 30 years based on our econometric input-output model, which is one of several models that we maintain in REAL. We have not only this model, but we have a computable general equilibrium model. We have a series of autoregressive models that we use to sort of monitor the growth and development of the metropolitan areas in the state. And also we have another one that we use for making housing price and sales forecasts for these same regions. The motivation for the work that I'm going to present comes from three different parts of the metropolitan region. For the first 10 or so years that REAL was in operation, we heard a lot of criticism coming, particularly from suburban mayors. We don't need the city. In fact, we can get on without it. We're doing very well. In fact, it's probably regarded by them as a sort of a negative component. And so one of the issues that we wanted to explore was how economically integrated is the internal structure of a metropolitan economy. The second issue focuses on probably one of the hottest topics right now in the policy arena, and that is the role of inequality in development. And given the fact that Chicago is probably one of the most racially segregated cities in the world, a development organization called Chicago United, which was formed in 1968 as a response to some significant unrest surrounding the Democratic National Convention that was held in the city. One of the things that they wanted to be able to show was if we pay attention to the least developed part of the metropolitan economy, will there be significant spillover effects to the rest of the region? And the third particular issue was the degree to which most of our modeling has operated at one level in the space. And as Alex will probably confirm, that is a difficult enough challenge to accommodate most of a lifetime to try to address the issues surrounding it. But one of the things that we wanted to try to do is capture a sort of a multi-level perspective. And this was sort of generated by the sort of fiscal federalism ideals that we should devolve a lot of responsibility to the lowest level possible so that individuals can, according to my PhD advisor, Thibault, vote with their feet and move to the community that offers the bundle of goods and services that will maximize their utilities. But the perspective we wanted to explore is this optimal at the metropolitan level? So those are the topics that will motivate the work. The analysis that we're going to conduct is, as I said, based on this input-output econometric model. I'm not going to go through the structure. There are several papers that are listed at the end of my presentation that you can look at to explore the structure. But it is not a conjoined model. It is an econometric model in which the input-output system is embedded. And one of its significant value added or characteristics is that it does allow for endogenous coefficient change as we move forward. And we usually make projections through, at the moment, 2050, so 30 to 40 years into the future. And this is what the structure of the model looks like. And all of this then is embedded in the system. And the coefficient change then is one of the most important characteristics, as well as a link with the demography, looking at population by age cohort and in and out migration. One of the main features in the last few years has been attention to the disaggregation of the household sector. And one of the things that I've always found surprising is so many of our models persist in using a representative household. And this is somewhat unfortunate because 70% of gross product on the expenditure side is accounted for by household consumption. And we collapse all of that heterogeneity into one particular sector. So what we have done is explored various forms of disaggregation by space, different parts of the city, by income level, by age, and soon we will do this by activity status, particularly in migrant versus out migrants. And all of this then has now been embedded in the system, so we have much more, if you like, sensitive forecasts of our economy. And in the analysis that we have conducted, it turns out that we get analytically very different results when we do the household disaggregation. For those of you who are not familiar with Chicago, we are located by Lake Michigan, and we use two different subdivisions of the economy in this analysis. And the first one, we basically focused on the subdivisions of the city into a central area, the rest of Chicago, the inner suburbs, and the outer suburbs. And what we were trying to do is look at a structural decomposition of those interactions, starting off with the inter-industry flows from our multi-zone input-output tables. Then we generated from those actions wages and salaries. We had journey to work data that enabled us to trace the flow of that income from the zones of work back to the zones of residence. And then we had an additional set of data which enabled us to move those wage and salary incomes from households to expenditures. So we had journey to shop data. And when we put all of that together, we then had the flows of total expenditures by zones. And I'm just going to show you a very small sample, visual sample of some of the results. If I sort of had left it there in terms of the interactions just between industries, in terms of goods and services flows, the suburban mayors would have been correct. The degree of interaction across zones was very, very small. And you can see for the most part, somewhere between 90 and 94% of the interactions took place within those zones with very, very little interregional trade. But when we started tracing the income effects and we started tracing the expenditure effects, we got a much more integrated city as a result of this. And so we had variations from around 47% in the rest of Chicago to a high of around 64% in the outer suburbs. But you can see that a significant portion of the total activity was generated outside the region. And I think this was very important for us to understand that these spatial internal dynamics were important, they were complicated, and they were much more integrated. And so just to conclude this part, here is a focus on the central business district, and you can see about 48% are generated internally, 26% come from interactions with the outer suburbs, and then the rest are divided between the rest of the Chicago region and the inner suburbs. A little bit less interaction between the outer suburbs, but still over 36% of their activity is generated outside that region. And this sort of summarizes those impacts and talks about them and describes the sort of structure that we're involved in. So that was important for us to understand that we have a city which is very complex. The sort of work that Michael Batty has been doing in trying to understand systems of systems within inside metropolitan areas, I think really confirms that sort of approach as being very, very important. But one of the things we wanted to do is say, given those degrees of interaction, what happens if we have a particular focus on one of the areas within the city, particularly on the south side of Chicago, which has traditionally been, one, the most segregated part of the city, and secondly, the part of the city region that has the lower of the incomes per capita in the region. And so what we did is appeal to a decomposition proposed by the Japanese economist Kenichi Miyazawa. And it's an example of what others like Beatty and Madden have referred to in their models as a sort of an onion skin approach, where we gradually unbundle those interactions. And what we wanted to do was look at how changes in economic interactions affected income distribution, status in the labor force, and migration behavior, and how the effects of changes in consumption spending, employment status, and so forth affected economic interactions. So we were trying to look at a more general equilibrium understanding of those interactions, but with a specific focus on income. And Miyazawa's framework basically proposes a disaggregation of the economic interactions with those centered on the inter-industry part, separated from flows of wages and salaries, and the effects of consumption in the region. And these then were disaggregated, in this case by space, in other cases by income, age, and activity status. And just doing the math here, we're essentially having a much more closed economic system. And what we end up with is a way to disaggregate the interactions to separate out the inter-industry part from the income receipt and income expenditures. And the most important part is this interaction here, CKVB, which essentially is a journey or around the network that brings together the inter-industry interactions with the receipts of income and the expenditures. And the most important component of this is a matrix K that Miyazawa referred to as the Miyazawa Interrelational Income Multiplier, or we can think of it as a generalized Keynesian multiplier. It traces how income earned in one region or by one group of households differentiated by age or income generates income to other parts of the region or to other groups. And one of the interesting questions that we wanted to explore was whether this was symmetrical or asymmetrical. In other words, if the income generated by region R on region S is larger or smaller than the reverse flow. And this was sort of a very interesting exercise. And this is where trying to frame this very dry analytical contribution into something that, that could appeal to the policymakers. And so what I tried to do, only partially successfully, I must admit, is to draw on thinking about trade theory and basically posit the notion, if there are gains from trade and independence in general between nations or between regions within nations, should there not be some expectation of something similar happening within a metropolitan region? And this was to try to get at this notion that if we help a region which is relatively lower in the economic status, will there be some positive effects, positive contributions to the rest of the economy, or will it be self-contained? And I think that while that may seem very simple and very naive, from a policymaker's perspective in the region, it was very important to demonstrate that there would be positive system-wide benefits. So once again, we explored the sort of thing we did in the first part, looking at flows of goods and services, flows of labor, flows of income, and then the movement of income in terms of its expenditure. And we did this in terms of a four region, which was slightly differently differentiated to provide more disaggregation within the city of Chicago. So the most prosperous part of the region is this one, which is to the north of the central part, the loop of Chicago. The least prosperous area, which was the focus of attention, is the south side. And then the west side of Chicago is a rapidly changing region with a lot of minority populations, particularly of Latino origin. And a lot of people don't perhaps aware that by 2030, something of the order of 37% of the metropolitan region's population is going to be Latinx. So it's changing very dramatically. So just to highlight a couple of things from the analysis, this is Miyazawa's interrelational income multiplier matrix. What we have arrayed on the as rows and columns are the four regions. And what this tells us, if you increase income in region one, what is the total contribution to the regional economy? In this case, an additional 81 cents of income. And how is that spatially distributed throughout the regions? So an additional 23 cents stays in region one, but 44 cents goes to region four, the suburbs. And we can do this for each one of the regions. One of the most interesting characteristics of this matrix is its pronounced asymmetry. So the focus of our attention was on region two. It turned out that the less prosperous region, for reasons that we'll see also a little later, generated the largest multiplier effect on the economy. And that's partly because low-income people tend to have very high propensities to consume out of their income. But if you look at the spatial distribution, you'll see that 56 cents of that $1.99 in total ended up in the outer suburbs, the suburban regions. But if we go to region 4, that region, when they have an additional increase in income, they generate in total $1.90, but only 5 cents of that income goes back to region 2. So you have an amazing asymmetry here. 5 cents of an additional dollar of income in region 4 goes to the second region, but only, but in contrast, 56 cents from the second region goes to the suburbs. And so what we see here is something that for the policymakers was incredibly unexpected. In other words, if we manage to add more activity into that region, then there are going to be significant spillovers elsewhere in the economy. And here is where I tried very hard to appeal to trade theory and to sort of characterize this as an example potentially of something we might call trade diversion. In other words, if you put more retail activity in the South Side where we have essentially a retail desert, that means a lot of people are going to be shopping locally. Surely that's going to have a negative impact on the suburbs because people are diverting their expenditures from one region to another. However, as a result of that development, we have new jobs in the second region, and the volume of spending in that region is going to go up. And given American shoppers' love of variety, we can make every expectation that the amount spent outside the region would increase, even though the share outside the region may decline. And so what we would end up then is a benefit to other regions in the economy from growth and development that took part in the South Side. Unfortunately, as I found when talking to policymakers, if you have to make too many steps in a process to explain what is going on, you often find a great deal of attrition in terms of understanding. And this was one case where that just was not able to resonate. I was not successful in getting that across. The final part that I want to just give you a sample from is looking at the whole issue of income inequality in the city. And I've always been somewhat frustrated with the use of Herfindahl and Gini indices, because part of the process there is, while one can estimate these things over time, the mechanisms by which they increase or decrease is often not provided in a way that we can understand. So what we wanted to try to do is see whether we could exploit the Miyazawa system to help us look at this process of income formation within the metropolitan economy over time. And our model goes from 1970 to 2050. So potentially we could have a very, very long time series to explore these data. And so what we wanted to do then is to look at this, but to expand the concept of income to move beyond wage and salary income, because as Piketty, Stiglitz and others have reminded us that there is an increasing share of income being generated by non-wage and salary income. So what we wanted to try to look at was the system-wide implications of income inequality and how that might be evolving over time. And so the basic system we put at is traced in this circular flow here. We have an income shock, and this then leads to consumption, which leads to output, which generates income, and so on and so forth. So all of that is captured within our model. And so we used that notion, this expanded notion, within our econometric input-output model. And there are a couple papers I've listed that show how we estimated the consumption using a modified almost a day demand system, and then used some Bayesian seemingly unrelated regression model using the Metropolis-Hastings algorithm to assign the income to different sectors and to different income groups. And what we found is, not surprisingly, significant variations in the propensity to consume. This is by age group. If any of you had children, you know that they spend much, much more than they earn. And then as they get older, that share declines until people enter retirement, when their propensity to consume starts to rise again. And what we found is that this propensity to consume by quintile was very, very different as we moved across the income side of it, not the age side of it, with the lowest income folks having very, very high propensities to consume. And this comes about from the fact that they not only receive wage and salary income, but a lot of transfers and government support programs. As you move up the income stream, as we found in a lot of empirical studies, that propensity to consume begins to decline. So a couple of things that I will just highlight in the last few minutes of my presentation is that we can look at the effect of changes in age distribution. And one of the things in our model is we are seeing a significant structural change in the demography, with folks in the prime age group of working age 25 to 44, for example, declining, whereas the people in the age group 65 and over by 2030 will be close to 1 million more in population. What impact is that going to have on the economy? Well, one of the things that we have discovered from this is that, there are significant changes in the indirect effects. And one of the most important dynamics is that we are seeing decreased spillover effects to the lower income groups. Those are lower age groups, those are people under 44 years of age, and higher increase in the share that is going to the higher income groups. That's the 45 to 64, and then the folks 65 and older. And this dynamic is very important for the reasons that as people age, they change their consumption profiles. So the economic impact of these structural changes in the population distribution are going to have a significant impact on the types of goods and services that are consumed. And in turn, there will be a different impact on whether these goods and services will be produced locally or whether they will be imported. So we are seeing a combination of economic structural change that is being generated in large part by a demographic structural change. We're able to do, as I said, analysis over time, and this is just a sample of those interrelational income multiplier matrices and looking at some of the changes. But what I want to do is just sort of focus on one of them and ask the question, are we seeing something analogous to the spatial asymmetry that we observed earlier when we looked at this in terms of the impacts of development on the south side in terms of the income distribution? And the answer is yes. And so I've just focused here on the lowest income quantile and the highest income quantile. And these percentages here are the share of not the total impact, but the share of the indirect effects. And one of the things we notice here that's very, very important is the intra-group spillover effect is very small. In other words, when low-income people receive an additional dollar of income, it generates very little spillover effects to other members of the low-income group. But there's very, very large spillover effects to the higher income group, 25% to the fourth quintile and over 50% to the highest income quintile. When you look at the highest income group, you notice a very different spatial distribution. The lowest income group only receives less than 2% when the highest income group receives $1 of additional income. Most of the impacts are very highly concentrated. Almost 75% are concentrated in the highest two income groups. So one of the reasons that income inequality persists is as a result of this asymmetry. And I think that this is an important addition to the foci that has been generated mainly based on Gini or Herfindahl indices in a sense that we can really begin to understand some of the dynamics. And just very quickly, we're able to look at the origin distribution of changes in the income distribution. So here we find that the largest multiplier effects are in the lowest income group, but when any income group changes its income or expenditure patterns, there's a huge degree of concentration in the higher income groups. So we have this enormous asymmetry, which is enhancing and exacerbating the income inequalities over time. Finally, I have 1 minute left, so I'm just going to tell you what we did in this hierarchical issue, and that's looking at land use forecast, but as Alex's model, ReLU, does this in a much more comprehensive way. My dimension is much more in terms of this decision-making about local versus metropolitan-wide. And what we've done is, this is the structure, the sort of stylized structure of our model, the interactions between the economy, employment, population, and income generation. What we've added to this is a land use component. And this goes from the region-wide level, which is 7 counties, down to 296 municipalities, and then down to 30 by 30 meter square land use model. And this is developed with a cellular automata model developed by my colleague Brian Deal as part of LEAM that is I think pretty well known. In modeling this, what we wanted to ask is, given our forecasts of the region's population, can they be accommodated? Given the fact that local communities have land use control. So we have 296 land use planning agencies within the metropolitan area. They have complete control over that land use. And as a result, we find enormous variations in the capacity to absorb population. Some communities have minimum lot sizes of around 2 hectares, which basically precludes the development of multifamily residences. So we used a model that Carlino and Mills expanded, and later Marlon Barnett put in a spatial econometric framework, essentially to look at the interaction between population and employment, and added a set of explanatory variables that were different for population than they were for employment. And then what we were able to do is get an expected level of population given the structural dynamics over time. And we did this for Chicago. And just a couple of summary graphs here. The most important finding of this work was that when we had an unconstrained forecast compared to the spatial econometric input-output model-based forecast, we had something of the order of 5% difference in the population by 2040. And that's 5 to 7% of an anticipated population of around 10 million persons. So you can see it is a very large number, around 500,000 people that could not be accommodated in the region. And so the implications that we explored is, where would they live? Or will the firms decide, given these population constraints, they will not locate? The differences in employment were trivial. There's a lot of capacity in the region to accommodate additions to employment, and so that was not an issue. So in summary, I think there are important spatial and household heterogeneities that are certainly exacerbating our income inequalities over time. And I think that a lot of the intervention that is being proposed has, I think, been misplaced because it has not really fully captured the feedback effects of the sort of general equilibrium framework that Alex is going to talk about in the second part of this presentation. The degree of levels of interdependence within the metropolitan area are very strong, but their character varies depending on where you locate. And finally, the sort of fiscal federalism implications suggest that we need to look at this vertical dimension and not just assume that communities can go ahead and make those decisions. They have significant positive and negative spillover effects that are often not captured, and then they do have this hierarchical effect. And I think that what we need to do, and like Alex, I'm looking for some good people who might be interested in trying to explore the way we can integrate all of these parts together so we can look at structural changes, internal mobility changes, and income distribution dynamics as one package. Thank you very much. The last slide provides the list of publications on which these are based. Thank you.
Thank you very much, Jay, for your sharing of the system-wide implications by using your region economic metric input-output models. I would say this is a pretty comprehensive presentation, and I think it actually includes a number of your work in a number of papers. I probably forgot to mention that actually for the audience, if you have any questions or comments, you can type into the Q&A box, which you can find at the bottom of your screen. So you can type into that and we can then figure it out. So while we are waiting for our audience to digest and think about their questions, could I invite our discussant, Michael, to share your comments on Geoffrey's presentation and probably to ask the first questions. Thank you.
Thank you, Tianren. I will have to start by confessing that this discussion poses difficult problems for me. And I had to make myself familiar with the work of Miyazawa before I continue in looking everything. Let's start with the three important problems which Geoffrey mentioned: the city-suburb tensions, spatial inequality, and all this needs to be addressed in a multi-level analysis. And I completely agree with that. You know, in my past experience, I realized there are basically two types of urban economic models. One is working with production functions, most familiar to me, and the other is connected, is using input-output formats. And the interesting and laudable and impressive in the model Geoffrey was presenting was that they combined both approaches, and that, of course, is a new type of regional economic impact model, which he demonstrated very impressively. It combines an input-output model and an economic model, the two types which I mentioned earlier, and he does so with an impressive list of variables and 45 industrial sectors, etc., etc. That, of course, is great. What is less impressive is that he does everything with 4 zones, and this is in contrast to my experience, where all our modelers really try to exceed others by looking at a high spatial resolution, where there are not 4 zones, but hundreds of zones, to be true. Okay, now I was very grateful for the short introduction into Miyazawa's extending income matrix, which he proposed as a novel way of modeling the endogenization of households' activities. And that, of course, I can only admire, because none of the input-output modelers I know have in the past really done that. So the extended demo-economic modeling, working with the K factor, the interrelational income multiplier of Miyazawa, is really an extension of the present state of the art, and we should be responsive to that. The summary really revealed the important spatial and household heterogeneities, yeah, and the enhanced levels of interdependence of household in different locations, yeah. But I also would like to finish with two questions. May I, Tianren, may I ask the speaker two questions? Okay.
Sure.
Now the first question is, yeah, could it be that the very large degrees of spillover revealed in your analysis were caused by the fact that you does all that with only 4 regions? So very aggregate trip lengths or accessibilities, and how could you deal with that problem? Maybe I stop here and ask you to answer this question.
Well, thank you very much, Michael, for taking this time. I did not want to burden you with having to read a lot of material, but I'm very, very grateful for you to do that. We thought about this a lot, and I think the last presentation is our compromise. And I think that what we are really trying to get at is, I think there's some sort of economic integrity in modeling the economy at a more macro level. And if we think about labor market behavior, in other words, 90% of the people living in that area are working in that area. So it has some degree of integrity. But what we wanted to think about is, do we try to drop that down to these 296 communities and then to the thousands and thousands of 30-meter square zones? I think that would be an impossible task, and I'm not sure I could justify it from an economic perspective. But when it comes to things like movement of people and consumption expenditures and land use decision-making, then I think it makes sense to have a much more disaggregated version. So your first comment about agreeing that we needed to have a hierarchical process, that's what we're thinking about. So we just don't think we can justify in terms of the quality of what we would find by modeling those interactions at the same level for thousands and thousands of 30-meter square units. But what we can do, I think, is do a much, much better job in terms of the movement of the people, work to home basis. And I think you will find with Alex's model that a lot of this is captured, perhaps not quite at the same level of sectoral detail, but at least I think it does a better version. So I think we're coming in this direction and Alex is coming in this direction.
Okay.
And somewhere there is an optimal version. But I do like the idea of not trying to put everything at one level. There are certain things I think that are much more, say, at level 1, economy-wide, metropolitan-wide, and other activities.
Okay. Thank you very much for this detailed answer. I will continue to think about that. My second and last question relates to the title of our seminar series, which is Modeling the New Urban World. And as I'm one of the, let's say, discussants of the organizing team, even though the organizing work was done solely in Cambridge, yeah, we were much interested in asking speakers to discuss a situation in the future, and we were mostly concerned with 3 types of influences. The first is climate change. The second is digitization, yeah, and last but not least, the current COVID pandemic. So if the model you were presenting works fine with present conditions, what do you think how will it work in the future after the pandemic, after digitization, and after a solution to climate change?
Okay. You left the most difficult question to the last of the two, Michael. Thank you. Let me answer it this way. Right now, we are trying to see how we would need to modify our forecast in view of this. And I tend to be a little bit concerned about assuming the sort of exaggerated hyperbole that I've been reading right now. And I recall in the 1970s, when energy prices rose very dramatically, we had a lot of people writing papers saying that people are going to move back much closer to their work because this will save them energy costs. And what they completely missed was the fact that the additional increases in energy were 2 or 3 percentage points, but the cost of relocation was significant. It was 10 or 15% of their income. I mean, it's very expensive to move house. As a result, after some initial turbulence, things went back to pretty much the way they were. So now we have the question is, are people going to move out of the city? Are they going to look for suburban locations? So are we going to see increasing pressures on suburban locations? Will there be more activities continuing to work from home rather than having physical locations? So what is this going to do to commercial real estate? And we've already seen significant declines in occupancy levels. The question that I'm still trying to disentangle is the degree to which these are short-run responses as opposed to some sort of longer-run trend. And I think what we're going to end up doing is essentially developing two scenarios, one in which this is just a short-run degree of turbulence, and it will change as hopefully we have a vaccine and things begin to settle down. I think that one of the aspects that we have seen that's probably affecting our forecast more than anything else is the millennials. Their behavior has been very, very different in the sense that they're not buying houses, they're not buying cars, they are flocking to the central parts of cities. And as a result, a lot of businesses have moved from the suburbs to downtown Chicago over the last 20 years. Is that going to unravel? And are they going to start to move back? Or again, will we find a year from now that people say, well, I thought about it, but I'm going to stay where I am because I like the amenities of the central city. So I think the only thing we can do right now is, I think, do this by some scenario, because I just don't think we have enough information. As far as climate change and digitization, those are issues that we have looked at a little bit, but not in a formal sense. But I think they are all going to be mapped up into, I think, our need to be much more flexible in our thinking and not assume that the economy is only affected by what happens in the economy. And I think your message to me is, look outside. Thank you, Michael.
Thank you very much. Yeah, Tianren, I think this was the last of my questions. Yeah.
Yeah, thank you, Michael. And actually, we got one quick question from the audience, and probably we will answer that first, and then we will turn to Alex for his presentation. So the question is from Ms. Pan. I think it's she. So could you please give some example of the positive and negative externalities to evaluate welfare gains and losses? And I think that's the first part of the question. And I think the second part is like, how will the evaluation of these welfare gains differ for different spatial scales? I think the second half is also correspond a bit to the Michael's query about the dimensions.
I think that what we did, for example, in the first exploration of the income relationships, is to be able to show how different types of initiatives. For example, I mentioned that the south side of Chicago is a retail desert, and So if people want to shop, other than buying very, very fast food, they have to essentially go to the suburbs. So one of the policy initiatives was to try to develop retail activity. And a lot of business folks were very, very nervous about this because they had this sort of pejorative notion that people didn't have money in the south side of Chicago and they would not be successful. And a do-it-yourself store located in the center part of the south side of Chicago. And in the first 6 months, it did its highest new business of any new store opening in the US. And what that provided was some incentive. And once one thing was located, then it sort of generated some positive externalities for other activities to start to move in there. I think that what people learn from this experience is that it's a very slow process and that it requires a great deal of thinking. At the same time, the housing stock was under a lot of pressure from gentrification, not from white people moving in there, but from wealthier Black folks moving into the community. So that dimension we were not able to capture in this type of model. But I think it reflects the fact that once you move into the policy arena, one has to be essentially much more comprehensive in terms of how you incorporate these things and to try to do the impact analysis. And I think you're right. In the interest of time, I will just say the response I gave to Michael would address the other one. Thank you, Tim.
Thank you, Geoffrey. And thank you, Michael, for your insightful comments. And our second speaker following Geoffrey is Professor Alex Annas. And he is gonna share with us about his work about the regional economy, land use, and transportation model, or in short, value trend model. And he will focus on the productivity benefits of urban transportation mega projects and using Paris as his case study area. Alex, I will hand over to you.
Okay, thank you very much. I would like to explain that this is joint work with Hubin Chang, who is my co-author in this paper, and a couple of other forthcoming papers. I'm not sure he can join today, but he is in China, and we've been working remotely with each other. So let me explain. So this is the regional economy, land use, and transportation model. A link is provided to the audience so you can check previous publications on this, which are all included in my website, can be downloaded, etc. And this model is basically what an economist would call a computable general equilibrium model. It's a multi-equation structural model that can accept lots of different parameter values and make simulations to see how things would change in a metropolitan economy. It's an equilibrium model. There is a dynamic version of the model, but its data requirements are not always satisfied. So in this study, we're using the equilibrium version of the model to do various simulations. What are these simulations about? These simulations, as you will see in a minute, will be about the introduction of a very big public transportation addition to the Paris region. But before I go into that, so this is the link where you can get the papers on the Relutran, and these are some of the characteristics of the model. In the model, jobs and populations are endogenously determined and can appear anywhere in the region where, for example, production can make a normal profit. That means there will be production in such a location, and there will be jobs created there. And then the labor markets and the housing markets will all be affected by this. So the basic microstructure of the model is that a consumer is also a worker, and a worker makes joint decisions of where to work, where to reside, and how to make shopping trips from that location, what kind of housing and size of housing to consume, how labor supply will be determined. And because of these decisions, you can also calculate non-work trips and commutes or work trips. As well, you can see mode choice and route of travel for each trip on the network, the highway network. The model endogenously calculates congestion, and it's also designed to experiment with congestion tolls to see how the congestion tolls would affect things, and we will talk about that later. So firms on the model choose, as I said before, they locate where they can make a normal profit. They choose input combinations, purchases from each other, export, import, output level. Their constant returns to scale and competitive, make zero profit at equilibrium, zero economic profit at equilibrium. And some of these features in Paris could not be implemented because of data limitations, but most of them were. There's also developers in the model, and they build or demolish buildings. So for example, you can demolish a building, create land, and then that land can be converted back to another type of building. This is a cyclical process, but it's modeled as a stationary process in a static version of the model. So there's always some building stock adjustments going on. And finally, the government is implicitly in the model because they collect taxes, set congestion tolls, and those kinds of things. So this is kind of a very quick description of the model without getting technical about it. But in the papers that are listed, you will find that I'm always careful to put all the equations in an appendix or in the paper itself. So everything is there. These are flowcharts about the model were published in the initial paper with Liu in 2007. And it's a traditional way of solving the model is to use the regional economy land use model and the transportation model and iterate between the two. So the regional economy land use model takes travel times travel costs as a matrix given. It calculates a lot of stuff about the economy, and in the process of doing that, it generates trips. These trips are fed into the Tran model, and the Tran model does the network assignment, the model split, and so on. And there's various ways to check for convergence. And each of these boxes have more detail in them. So this flowchart shows the ReLU box. It's broken into many other boxes. And the reason these boxes are arranged this way is not arbitrary. It just turns out that the system of equations is block recursive. So a natural way to solve the problem is to calculate product prices given all the other variables that are interdependent, then calculate outputs, then calculate wages from the labor market and rents from the housing market. These two can be switched around. It doesn't affect the final calculations. Then calculate values of buildings and land, and from that calculate land adjustments. So this is sort of a pretty accurate description of how the model is solved and what variables are taken as given at each step and what other variables are calculated. For example, given wages and rents, the model calculates product prices as a system of equations. It doesn't have fixed input-output coefficients, but it has a generalized structure so that if you make the different inputs, for example, very complementary, then you get something very close to Leontief. So that becomes very close to an input-output matrix. Prices are endogenous in the model, so the value-based coefficients are always changing as the economy changes. And then this is a traditional description of how the Tran model works. You do mode choice, then you do route choice, then you calculate congestion on the network, and then you update trips, which go back into ReLU. Okay, so the Paris region is in this study. It actually has a very detailed underlying structure of 3,000 zones, but not all the data is available at that level. So that's one reason we couldn't do it at that level. Another reason is that computationally it becomes quite horrendous in the sense that the run takes almost a day or so at that level. So what we've done is we've aggregated the model. And there's other reasons for the aggregation I will explain in a minute. So that this is a 53 zone definition of Paris. Paris is this fish-shaped area in the center, shown here in the inset, that has 20 zones, the traditional arrondissements of Paris. Then there are the pink zones, which are inner suburbs of Paris. These are much higher density than the yellow zones, which are the outer suburbs. The dark pink zones are selected by the planners for various reasons. They believe that these should be growth poles in the future. So what the planners want to know is if they build this transportation system, which I will explain in a second, will these dark pink zones, or some of them, become really great employment centers in the future? That is their main vision about how Paris should be in the future. Paris, as you might know, is entirely developed. There's very little vacant land inside of the city of Paris. And there's, as you know, a very beautiful skyline with exceptionally historic buildings and so on. So there are height limitations. So development in Paris is undesirable and not allowed. So the housing stock in Paris in the model is treated as more or less fixed. Very few changes can happen there. But the transportation project I will describe in a minute links some of these dark pink zones with each other, you know, as inner suburbs with each other, so that in the future, when growth happens in the Paris region, it is hoped that this growth will go to the dark pink zones and they will be able to communicate efficiently with each other without overburdening the transportation system inside Paris. In other words, without using the radial lines, but circumferentially communicating with each other. So the proposed project is sort of, very roughly speaking, doing this sort of thing, linking the pink suburbs to each other. I will show you a map in a minute. So the idea is to decongest Paris over time. So in other words, come up with various schemes to draw more population to the inner suburbs, both from the outer suburbs, because they don't like sprawl, so you want to draw population from the outer suburbs to the inner suburbs. At the same time, decongest Paris and draw population and jobs, especially jobs, from Paris to the inner suburbs. So that's sort of the idea behind the transportation project. So here you can see that the gray area is the city of Paris, and the red and the green lines, and some of the blue lines as well, are what they propose to add between now and 2035. I believe construction is underway. It started a couple of years ago, linking these dark pink colored suburbs in the previous map to each other. So that's the idea. So what we're doing in this application of Relutran is to see what would happen if this project is built. How would the economy respond? And most importantly, we want to see if the project is beneficial. In other words, calculate social welfare in a pretty sophisticated way, I think, and then see if the project is beneficial. In other words, what is the social benefit to cost ratio? And also use congestion tolls, which the French absolutely do not want to do, but I don't really care. I'm interested in that, so I will impose congestion tolls on the road network and see whether the revenue raised with congestion tolls will be helpful in defraying some of the cost of this project. The project is projected to cost 35 billion euros in present value costs, and recently there's been some reports that it's going to slip up towards 38 billion. A paper was written under the assumption of 35 billion, but it can easily be changed to 38. And so we're interested in looking at social benefit cost ratio and public cost recovery ratios. So those are the two important things in the cost benefit analysis. And we also, of course, want to know how much are the social benefits as a percentage of income in the region, of average income in the region, that sort of thing. So now in doing this, of course, there is a very long-standing interest in calculating the benefits of transportation projects. And many of you know that there are a couple of ways of doing it that are important in the literature. One is that the projects create accessibility improvements, so therefore they are beneficial because they make it easier for people to travel, which saves resources, time. Also, a public transportation project can potentially reduce congestion on the roads, so it's beneficial in that sense as well. But the other literature is known as the wider benefits of transportation projects literature. And this claims that there are general equilibrium effects, so there could be rent increases, there could be changes in the job market, and these are non-user benefits that accrue to transportation projects. But more importantly, the transportation project can improve accessibility, which makes Marshallian agglomeration economies more likely to occur, or improves the level of Marshallian agglomeration economies so that industry, maybe some industries, not all, industry becomes more productive. So there is this thing here, start from here. So the PGB Projet Grand Paris is built. If that is built, public transit travel times are reduced. And these are taken as given by us because they've already pre-calculated as projected improvements in transit travel time. So the model doesn't calculate those, but take those as an input. Then this causes trips to switch to public transit from car, mostly. That reduces road congestion. So car travel times fall, accessibility improves. Now, when accessibility improves, that of course increases consumer utility, and consumers then relocate. They make adjustments in where they are. They also make adjustments in how far they want to travel for shopping and those types of things. So that has an effect on the economy, and it affects the distribution of jobs and population among the zones. That can affect rents in the housing market. So these pictures are in my way here. You can't see that, but I can. So let me move that. So real rents rise, right? So some of these things create negative feedbacks because when the rents rise, that has a negative effect on consumer utility. So it takes away some of the initial improvement. Also, in the long run, as consumer utility rises, more people can come into the region. So the size of the region grows. In urban economics, we call such a model an open city model, actually, in this case, open region model. And that's going to, create more effects on everything else. But at the same time, there's another channel with a green arrow, and that shows that there's going to be direct effects on productivity from the accessibility improvement. Because if you believe in what Marshall said, he said that if jobs are closer together, then there is better positive interactions that affect production. So that would make industry more productive. In this model, I'm going to model that as a total factor productivity improvement, which means that the constant term in front of the production function will get bigger. That should have an effect on wages, or real wages, and it should also affect jobs and population distribution. So that's sort of a flow chart of how the model works. This is not in the paper because if you want to publish an economic journal, you don't want to have too many flow charts. And that's why it's not there, but I actually like it, right? So the in-migration, by the way, is going to have a negative feedback as well because as the project improves these things and more people move into the region, you're going to get some bounce back in congestion, for example. But it can also have positive effects. They are not actually here. Okay, so let me explain here how this is modeled. So the production function is the output produced by an industry in zone J as a function of different inputs, and there is a constant term in front of it. So in the literature, there have been theoretical work where that constant term is no longer constant, but it's made a function of the accessibility to jobs. So you have Fujita Nagawa in '82, Lucas Rossi-Hansberg, 2002, Anas and Kim. They cite Anas and Kim as an antecedent. Actually, in Anas and Kim, it's not a production function, it's in the utility function that you get Marshallian economies, but it works in a similar way. So what we're doing is taking this production function. We have labor inputs here, we have building inputs here, capital inputs here, and we're going to make this a function of something. So there is literature on this. Empirical literature has shown, starting with, I believe, Ciccone and Hall in 1996, that if you take the job density in zone J, jobs divided by area of the zone, and they use US counties, which are very big zones, then you get an alpha, which is this coefficient here, which is the elasticity by which the total factor productivity reacts to the density to be 0.06, which means that if you increase the job density by 10%, you're going to get a 0.6% improvement in total factor productivity. So it means using the same inputs, you would be able to produce that much more output because this coefficient is going to increase by 0.06, okay? Now, this was done by Ciccone again for France, so you got a different coefficient for France using French departments, which are roughly comparable in size to American counties. And the problem with this coefficient was that it didn't include any travel attenuation factor. So jobs anywhere in your zone would affect you positively, but jobs in other zones would not affect you at all. So this problem was fixed by Graham at Imperial College by introducing a discount factor based on the travel time between zone I and zone J. So that means that the total factor productivity of zone J is going to be affected by all the other zones I in the region. And the ones closer will have a more effect than the ones farther away. This depends on the coefficient beta, which Graham assumed would be equal to 1, but of course that can be changed. Many different values can be tried. Oops, so let me go one more step here to explain how we're doing this. So we're using a very similar formula, but we made some modifications. So we do use Cicconi's coefficient. In the paper, we use beta equal 3, but in the sensitivity analysis section of the paper, we also use beta equal 1. And we've tried some other betas as well. So the total factor productivity here is this equation where D is density, just like in the previous studies I showed you. But there is a zone weight, and the zone weight has to do with the jobs in the zone, the jobs shared in the zone. So a bigger zone would have a bigger effect. A smaller zone would have a smaller effect, ceteris paribus. A denser zone would have a bigger effect, and a less dense zone would have a smaller effect. And then there is the Graham coefficient. And we use TIJ, which is similar to, we use GIJ, which is similar or same as his TIJ. It's the mode-weighted average travel time. Right? So here we have the PGP travel times, which are exogenously improved. So they reduce exogenously, their values go down when the PGB is built. So when the PGB is built, you have more options to go between the zones using public transit. There's already public transit extensively in the region, but now you have a faster way to go. So you get travel time improvements. Then the model calculates endogenously the highway travel time improvements. They go down because if some people switch to public transit, that relieves congestion. And because Paris is so extremely congested, you get actually a very big bang from this. And then you have the mode choice probability, which is, the probability that you're going to use car or the probability that you're going to use public transit. So GIJ is the weighted average of travel time, average travel times, weighted over modes, right? Okay, so meanwhile, of course, as things re-equilibrate, the job distribution will change, so the densities will change, and the weights themselves will change. So these things are endogenous. They're given roughly by this equation, which explained in detail in the appendix of the paper. So this is basically given a total population and a fraction of population that will be in the labor force, what will be the number of people who will be working in zone J? It's a multinomial logit specification. That depends on wages, rents, product prices, travel times, travel costs, and by summing you get the number of jobs. Okay, so the properties of this equation is, as I said, what would be the effect on the total factor productivity in zone J? How is it influenced by jobs in other zones? This is the Marshallian externality. In the paper we call the TFP externality. So if zone I and I prime are equally accessible to J and equally dense, I has a bigger influence if it has more jobs. If I and I prime are equally accessible to J and have equal number of jobs, then the denser zone has a bigger effect. And if they are equally dense and equal jobs, the one that's closer, more accessible, has a bigger effect. So we think this is a sort of a minor but necessary improvement on previous formulas. And another thing we are talking about, especially in the introduction of the paper, is that if you improve the TFP coefficient, which in this case would improve endogenously because of this project, right? You're going to have three effects. The first one we call the intensive marginal effect. And this is a simple effect that if you improve productivity of a worker, because that's what the TFP will do, then you need fewer workers to produce the same amount of output. So in the very short run, there would be such an effect, which is actually going to reduce the number of jobs in a place, right? That's, we call that an instance of the Schumpeterian job destruction effect. So when I teach undergraduates microeconomics, I always talk a lot about this. So I give examples of this. So when I was hired at Northwestern University in 1975, there was one secretary for every 2 faculty members. Back then, you know, they used typewriters to type papers. So very few professors that I know type their own papers. The secretaries always did. You had to write your papers by hand and so on. When I left in 1991, there was one secretary for every 4 or 5 faculty. What had happened is that the PC came around in the 80s. So one day I came to the office and there was a big box on my desk. So I started, after a while, I started typing my own papers. Secretaries were not as needed. Meanwhile, the secretaries themselves became more productive because they also used PC. So you didn't need as many secretaries. What had happened is that the PC improved the productivity of a secretary. The number of secretaries hired went down. That is the intensive marginal effect of productivity on employment, which plays a role in this model, but was not actually, as far as I know, mentioned by Marshall. Okay, so what also happens in industry is if you make the workers more productive, you're going to reduce the marginal cost of producing 1 unit of output. And in a competitive industry, even in an imperfectly competitive industry, but in this case, a competitive industry, price would come down. And as the price comes down, that's going to create another effect. So this should be number 2, extensive marginal effect. The higher TFP lowers the cost, lowers the price of the product. And so the quantity demanded increases and more product needs to be produced, and that will create more jobs. So effect 1 and effect 2 work against each other. Turns out in the model, they roughly cancel each other. Not exactly, but you know, close to that. And then you have a third effect, which is a super extensive marginal effect. And that's as the utility improves, because of the TFP externality, people become more productive. Actually, their real wages go up. In-migration increases population. And the higher population increases job densities, because higher population means more jobs too. So job densities increase, so the TFP improves, and you get a positive feedback effect. So once migration occurs, then you're going to have a positive feedback effect. So it turns out in the simulations, this is a very strong effect, and the other 2 roughly cancel each other, which is something has not been noted in the theoretical literature. So I'm also trying to write a short theoretical paper on effect 1 and 2. So when we actually do the simulation, and what's the simulation here? The simulation is just put PGP in place and the equilibrium changes. So calculate the changes and see how things change, okay? So what we have is that the CDTs are those dark pink zones where the planners hope they will grow. They do indeed grow. So they drove population out of Paris and out of the suburbs into the CDTs. Not a lot of population, but as you know, observable number. Okay, and this is without the TFP externality. Right? No TFP externality here. That means I'm keeping the A coefficient constant. Right? Now, if I make the A coefficient endogenous in the way that I explained before, then you get additional change. Okay, but it's very small. Okay, the reason is that effect 1 and effect 2, which I showed you in the previous slide, are offsetting each other, right? Okay, so this is population and this is jobs. So what happens is that both population and jobs concentrate in the CDTs, but they concentrate less because when we have the TFP externality, you get a reduction. Small, but still there. Okay. And the reason is you've made each job more productive. So that's the first effect, offsetting the second effect. Right? Price falls because of the efficiency improvement. The higher TFP causes price to fall. right? Again, let me remind you, so when the TFP improves, marginal cost falls, price falls, because price must equal marginal cost at equilibrium. That creates more demand. That would mean more jobs. But at the same time, you've made each worker more productive, so you didn't need less workers, so that would mean less jobs. So these two effects are working against each other, roughly canceling each other. We can see that the changes are small when the additional effect is taken into account. So both population and jobs concentrate in the cities, but less so when the TFP externality is present because of the intensive marginal effect working against the extensive marginal effect. Okay, and if we look at population and job changes due to congestion pricing, so what is this? So once we put the PGP in place, right, that was the previous page, we didn't do anything about congestion pricing. Now this is another simulation, it's just like the previous one, but in this case we introduced congestion pricing, okay? So it means that travel is now priced, so what that is going to do is reduce congestion, more people will be switching to public transportation, some people will be moving to areas where public transportation is more available, so that's ideally the city of Paris. And some people will be switching, you know, to railroads. If they're in the suburbs, they don't want to move. Those kinds of things are going to happen. So what you get is that when you do congestion pricing, population concentrates more in the city of Paris at the expense of the cities and the suburbs. If you have no TFP externality, and if you have TFP externality, it concentrates a little more, about 10% more. Okay, and that's population. And if you look at jobs, the congestion pricing pushed jobs out. Okay, the reason is that congestion pricing makes it difficult for workers to live close to their job. I mean, they're on the one hand, they're moving closer to their jobs, because, for example, more people are moving into Paris, so more people would be employed in Paris, but on the other hand, firms are moving out because of congestion pricing, because otherwise they would have to pay wages that are high. So trying to avoid this by moving to the suburbs where land is cheap and wages are lower. And so this is consistent with some of the theoretical work I've done before, like in the Anas-Kim and Anas-Zhu model. You see that if you put congestion pricing, employment decentralizes while population tries to centralize. Of course, they're interdependent, so you reach some kind of balance between the two. And again, if you have productivity, the additional effect is small. So far what we've seen is that the physical changes, by taking into account a Marshallian economy in production, are relatively modest. They are not very big, they're small. Okay, and this is using only short run. Short run means I'm not allowing in-migration, right? When I allow in-migration, then the effects get considerably bigger, and I will show those in a minute. So congestion tolls centralized population, okay? A little bit more so when there is a TFP externality than if there isn't. And congestion pricing decentralizes jobs, and a little bit more so when there is a TFP externality. Now, I want to talk about how I do the welfare analysis in the model. So we calculate social welfare by calculating the compensating variation of the consumer who lives in the region, but there is export, so we also calculate the compensating variation of people who live outside the region and the rest of the world, because they're purchasing stuff from this region. So when prices fall in this region, they benefit. Okay, so it could be the rest of France, but potentially it could include more people. Then we calculate the real estate gains, how much real estate prices change for each different type of building, summing over all the buildings and annualizing that at a certain interest rate. And then we calculate the public sector's gains. So there's tax revenues from income taxes and sales taxes in the model. And because things are changing, the revenues from these taxes could in principle go up or down. So that's part of the social cost. If they go down, for example, that's an additional public deficit that the project creates. So you need to take that into account. And if we do congestion tolling, then the congestion tolling revenue is also added into this. Okay, so that's how welfare is calculated in the model. And all the welfare calculations are then divided by the number of people reported on a per worker basis. So now let me explain the different things that can happen with this model in the short run and the long run. So what you see here is utility on the vertical axis and population on the horizontal axis, right? So the baseline equilibrium is this one. So this actually represents an equilibrium in the year 2035, because we've taken the planner's projections of exogenous population and some other things to the year 2035. Then we've synthesized economic drivers which would create those or would be consistent with those exogenous drivers. That's the baseline in the model. And so now what happens is that if the project is built, okay, so before I say that, let me talk about this curve A. Curve A represents the relationship between utility and population. And by simulation, by numerical calculations, you can show that the slope is negative, right? Slope is negative means that you can interpret it as saying that Paris is overpopulated. There is somewhere here where the slope would be flat, and that would be the optimal side of Paris. But Paris is on the right side of that, okay? And that's not unusual because economic theory shows that if you have big primate cities, which Paris certainly is, with 20% of France's population, it will likely be overpopulated because that's a stable equilibrium, okay? So now the model asks the question, what would happen if the project PGB was built? Well, if the project PGB was built, the black curve would shift up to the green curve position. So curve A would move up to curve B. If you keep the population constant, then there would be all those benefits we talked about. But suppose there is no TFP externality, and utility would increase. So the red arrow I just put there shows that utility would increase by keeping population at the baseline level, right? I'm not allowing in-migration. So it's going to cause an increase per person in utility. In this case, it happens to be 160 euros per worker, okay? Now, if I allow migration, what's going to happen is that population is going to increase by in-migration. So follow my red arrow. The equilibrium will move from the equilibrium at point B to the equilibrium at B prime, where things will go back to the original baseline equilibrium. This is under the assumption that before you put the project in, everything was in equilibrium. The city or the region was in equilibrium with the rest of the world. When you build the project, the region gets a tentative improvement in utility, but if you allow in-migration, consumer utility would fall because people would keep coming into the region until that advantage is dissipated. So then, in the long run, you will be at point B prime. So in the short run, you move from A to B. In the long run, from B to B prime. Okay. This is without assuming a Marshallian TFP externality. Now, if we turn on the switch and allow a Marshallian TFP externality, then the curve moves to a higher position, C. So in this case, what happens is if we keep the population constant, then the utility moves up from plus 162 euros to plus 340 euros. So there's an additional benefit. And that's what some of the transportation scholars call the wider benefit of transportation. Okay. Now, if we then allow migration again, because C is without migration, right, then it will move back to here, and so we'll move to C prime. Okay, so what you see here then is that if there is no TFP externality, then the PGP would increase the Paris population, the region, the entire region population by about 1.8%. And if there is a TFP externality as modeled according to the previous presentation, then it would increase it by 4.5%. Okay. This is without congestion pricing. So the same thing can be done with congestion pricing. So in the case of congestion pricing, the effect of congestion pricing on consumer utility could be positive or negative. The effect of congestion pricing on welfare is always positive. But here I'm just looking at consumer utility because migration is driven by what happens to the consumer. So in that case, you start again from A. That's the same curve as in the previous page. But now we have congestion pricing. So if congestion pricing has an income effect, namely it reduces the purchasing power of the consumer because they have to pay congestion tolls, right? That's actually going to reduce utility. Now I can get it to increase utility if I make the consumers value travel time savings very, very highly. But under our calibration, it reduces it. So we're here without population migration. And if we allow migration, then we move up to here. So actually, congestion pricing is a small negative effect on regional population without the TFP externality. And if we allow the TFP externality to be there, so it's a, one of these is a counterfactual simulation because you can say in the real world, we do have TFP externality. So the green curve is counterfactual and the red one is factual. Or you can take the opposite view if you want, right? So then what's going to happen is given the same population, utility would increase. And then in the long run, population would be bigger. So with congestion pricing, you get a 1.2% increase in population in the region. Okay, so these are the kinds of simulations we do. Now, another thing we discover by this type of analysis is different interaction effects in the model. Because we have traffic congestion, that's a negative externality. Then we have the TFP externality, which is a positive Marshallian externality. Okay, these are both market failures, because whenever you have a technological externality, that's a market failure, which means you have a mismatch between, in the case of traffic congestion, between the social marginal cost of traveling and the private average cost of traveling. The former is bigger than the latter. In the case of the TFP externality, social marginal product is bigger than private marginal product. Okay, so these are one negative, one positive externality. And the question is, what is the interaction between them? In other words, if you have more congestion, does that reduce or improve the TFP externality, right? So one simple-minded approach might be, well, assume that everyone works at the same place. There's only one place where people can work. If you have more congestion, then fewer people are going to want to work there. Maybe they work at home or they move out of the region or can do other things. So what that means is that you're going to have fewer jobs in that region. So the TFP externality will be reduced because the TFP externality depends on job concentration. So that's an example where traffic congestion and TFP externality would have a negative interaction. Now in our model, it's more complicated because the model is polycentric. There's jobs everywhere. And so when you introduce, when you have more congestion, that's going to change the distribution of jobs. And so in some places, the TFP externality will improve. In other places, the TFP externality will be reduced. Okay, so then there is a third type of market failure, which is because of the presence of distortionary taxes. We have income taxes and sales taxes in the model. So the revenues from these accrue to the government, so they are a social benefit because, why? Because they can offset a government deficit or the government can use these to do other things, which are not modeled, but we are calculating what happens to the government's budget. So if the TFP externality reduces the income tax or the sales tax revenue, that's going to be a negative effect, right? If the traffic congestion reduces them, that's going to be a negative effect, for example. So those interactions are things we're looking for in the paper. We find that there's a weak interaction between the traffic congestion externality and the TFP externality. And this contradicts or improves, I would say, some very simple theoretical analysis in the literature, which found a very positive effect, but they were not empirical, just simple theoretical models in a monocentric city where everyone works in the same place. We find a strong negative effect of the TFP externality on the sales and tax revenues. And the main reason this happens is because, as I explained before, the TFP externality reduces product prices because it reduces marginal cost. So price equal marginal cost means product prices are reduced. And this means that there would be less sales tax revenue. Not necessarily, but that's what it turns out to be. It depends a lot on the demand, price elasticity of demand for the product. So if we change that, we can get a slightly positive effect. Then there's also a strong negative interaction between congestion pricing and the TFP externality. Because congestion pricing dents disposable income, so therefore it reduces expenditures in the purchase of goods and so on. And so as price falls, wages and rents also fall in nominal terms, but prices fall more than wages and rents. So when you normalize wages and rents by product prices, then you get that real wages and real rents increase because of the project, and they increase more when there is a TFP externality. Okay, so let me continue. So these diagrams, simply the tax diagrams that illustrate the previous point. So what happens is when the project is built, right, price falls. So it's a perfectly competitive, constant returns to scale economy. So you have a flat marginal cost curve, which is a supply curve of the industry. So when you improve accessibility and you improve the TFP externality, this marginal cost falls, so price falls. So meanwhile, the demand shifts as well because more output is produced due to the lower price, demand goes up, so more output is produced. So what you get is from this sales tax revenue rectangle, you move to this sales tax revenue rectangle. And you can see that this one in the bottom can be shallower and longer. And so it can either be higher or lower in area, which is the revenue, than the one at the top, depending on the different elasticities. Okay. Similar things happen with respect to income tax as well, because wages are adjusted. Okay, so let me go to the welfare analysis. So what do we find in the welfare analysis? So here is a table, which is a part of the table in the paper, but this is a little easier to look at. So what you have here is the closed city. Closed city means no in-migration, the population is fixed. So closed open refer to whether it's closed open to population. So closed city means population is fixed. You have a simulation where you have no TFP externality and the total welfare per consumer increases by that much. And then this is the additional change if you have a TFP externality. In the paper, it's presented in a different way. This is from an earlier version where in the paper I present this same as here, and here I have the sum of the two. Okay, but it's the same thing. So if you look at this, you have to think about adding them up to see what the total would be if there is a TFP externality. And if you look at the paper, you have to subtract them to see the marginal effect of the TFP externality. Okay. So note that there is a very slight negative effect on real estate values, but note that there is a negative effect on tax revenues. Okay. For the reason that, again, driven essentially because of the price drop due to the efficiency improvement. So there's no congestion tolls. That's why this is zero here. Importers gain because the price falls, and they gain because the products are now cheaper. Right? Meanwhile, their incomes and all that is happening in the rest of the world. So those are exogenous. I'm not modeling the whole world. I'm just modeling the Paris region. Okay. The productivity externality has a very small interaction with the congestion externality. These are the values of the externalities calculated. In the appendix, it's explained how these are calculated. So they are the difference between, let's say, social marginal product and private marginal product summed over everyone who works, that sort of thing. And then we have the cost of the direct cost of the GPP, which is the cost of building it, and it also includes some operating costs. So the benefit cost ratio is 1.32 if there is no TFP externality. It's much higher, plus 2.39 more if there is a TFP externality. So this is good news for all those colleagues who've been working on the wider effects or the wider benefits of transportation projects. Right? They like to see, I assume, higher benefit to cost ratios than they've been getting. And in a general equilibrium model, this is good news because it means that even though there are these negative effects, right? Tax revenue decrease is a negative effect on welfare, right? Because welfare is the sum of these things, right? And the total benefit to cost ratio is still pretty high. Okay, and then we have how big is welfare relative to average income? So depending on who you show these results to. So French planners, they are disappointed because they would like the project to be even more beneficial, right? But they're not economists. Economists generally think that perhaps these are a little high because they tend to be cynics, you know, the dismal science stuff, right? Anyway, so people react differently. I'm not sure what I think because I'm mostly interested in modeling and of course, I want to make sense out of the numbers, but the qualitative effects are much more important than the precise quantitative things. So I'm much more interested in how these numbers change if I do sensitivity analysis. So in the paper, there's a section that does sensitivity analysis, and that there's a lot more that we could put there, but we kept it as short as possible, see how the referees will react to that. Now, in the case where the region is open to population, that means now it's just exactly like here, but I'm allowing in migration, right? So more people can come in now, okay? So if you do that, then as explained earlier, the consumer benefits basically go to zero. It's almost zero minus one euro per person, because that's by definition of the migration. The migration will come in until all this benefit of 162 euros is dissipated, because the higher population is going to cause rents to go up, etc. More congestion, so some of the bounce back in congestion, that will take away the initial utility gain that you got when you didn't allow migration. But of course, rents will increase because now you have more people competing in the same region, so it's going to cause a scarcity effect in locations, especially where there is very little vacant land, so enough housing cannot be built. So rents will go up. So that's a positive in terms of the welfare because it's going to add to the welfare component, right? And then tax revenues, however, still decrease more. Okay. Okay, so then we have importers still gaining. They're always gaining. In fact, if you allow the TFP externality, which is this column, so this, again, this column is without TFP, this one is the additional change with TFP. So now you get a very big gain by importers because the TFP makes the price fall a lot more. And so therefore, they're buying the goods more cheaply from the region, okay? So the productivity externality, again, has very weak interactions with the congestion externality, changes, but not a lot. And the benefit to cost ratio here is 1.1. And the welfare gain as a percentage of income is 0.37, okay, less, okay, than, it's less than if you had fixed population. Okay, and then this last part is about the effects of congestion pricing. So let me, in the interest of finishing on time, let me focus on public cost recovery ratio, right? So here there is congestion tolls. So what is this number? This is the number that tells us what multiple or fraction of the total direct cost of building the project plus the income and sales tax revenue losses can be recouped by the congestion toll revenue. Because the congestion toll revenue is a big deal because it's so congested that you raise a lot of money when you do congestion pricing. So that is 422 euros per person, per worker, okay? And the TFP externality is a weak interaction with congestion pricing, so it only changes it by an additional 3 euros. But you see that you can recoup about 0.7, in other words, 70% of the cost of the project, where the cost is the direct cost, which is 132 euros per person or per worker, plus the income and tax revenue losses per worker. Okay, so that's not bad. If you don't have a TFP externality, you actually recoup almost all of it, or all of it, a little more than all of it. And the reason for that is because with the TFP externality prices fall more, so you have more tax revenue losses than without. Okay. So this is just a summary of the same things here. I'll let you look at it for a second. And these are also from the same table, just summarizing the different things. Okay. And this is the public cost recovery ratios. Okay, so now compare this model to the literature for those who are interested in this stuff. There are some theoretical contributions, however, not all of them model the same thing. So here is us, and here is us, and these are some of the different things. For example, let me circle the most important things. We're the only model that's polycentric. We do both short run and long run. We're the only model that considers non-work travel. That's a big deal because if you look at the data, in the US, non-work trips are 75 to 80% of all trips in urban areas. In Paris, 75%, very similar. This is a big deal. Why is it a big deal? Because really more than 95% of urban economics assumes only work trips and everyone traveling to one central business district. No one really, except myself, looks at non-work trips in such a model. Of course, people have looked at non-work trips, find their work very useful, but not in a theoretical model. So a lot of the effects that I talked about come about because people are buying these goods that benefit from the TFP externality. The TFP externality reduces the price, and that's going to affect, how much shopping people do, etc., right? And that's going to cause output increases because the quantity demanded will increase because the price fell, even though we have this negative intensive marginal effect due to the fact that if you have more productive workers, you don't need as many workers. So all these things work out in a positive way in some sense, but there are negative effects like lower tax revenues from income and sales taxes. Buildings are only present in our model, so the other models assume either land, no buildings, or the buildings are not changing, that sort of thing. And if we look at wages, in our model, labor is paid the value of its marginal product, which is the correct way to model things in a competitive industry setting. But in some of the other papers, wages are exogenous, though incomes may be endogenous because people are deciding how many hours to work. So there is a labor-leisure trade-off that's very good to have. But in some papers, wages assume to be the private average product because it's a very simple model. And of course, that assumption could be changed. So we have some things that other models don't have in a more realistic setting where the model is empirically calibrated. Product prices are endogenous only in our model, not in the others. And export-imports are not present in the other models. So in the other models, the city is open to trade, but the price is implicitly fixed as a numeraire price. Okay, here the price is endogenous, so it has an effect on travel behavior and economic behavior. Okay, let me see. And so these are the conclusions. They are the same conclusions written in the paper. Quickly go through this. I start out the paper by saying that a lot of people view mega public transportation projects as white elephants What does that mean? That means these are projects that are considered non-beneficial because either you have cost overruns or the benefits are not very big. So politicians just create these projects for non-economic reasons. I think that is not correct based on the simulations. The projects have substantial benefits, as I showed you. But a lot of these benefits are very strongly depending on the super extensive marginal effect of in-migration. Okay. Congestion pricing has a negative effect because it dents disposable income, right, has an income effect. Although it has benefits because it saves travel time, so those benefits are not very big if people value travel time very slightly, but they're much bigger if they value it very heavily. The TFP externality reduces nominal output prices and wages, but increases real wages and rents. So it's beneficial in that sense. And the lower nominal output prices of traded goods confer benefits on those who import from the region. So people living outside the region benefit, which almost always is ignored in the cost-benefit analysis of transportation projects. As far as I know, I could be wrong, but a higher TFP causes the revenue from income and sale taxes to decrease, so that's a negative effect that needs to be considered. If you ignore that effect, you're going to overestimate the benefits of these projects. And a negative income effect of congestion pricing on purchasing power causes lower revenues from these same distortionary taxes, income and sales tax. So if you ignore that, then you're going to underestimate the project's benefits and so on. So the TFP externality is a minor negative interaction with congestion pricing in the short run and minor positive interaction in the long run. So these are the conclusions from the model. I think I'm done here. Thank you.
Thank you so much, Alex. It's quite a complicated model, but thank you for unwrapping that kind of black box to us and let us know about the interdependency between different sectors, as well as the different parts of the city, I would say. We are running a bit late, so I know that Jeff will actually go to another meeting. So I think, has he already left now? If in this case,
I believe he has, yeah.
Yeah. So in this case, can I just pick one quick question from the audience? Because actually we have a lot of questions, as you may already seen in the Q&A box.
Yeah, let me look.
Tianren, and perhaps I think with the permission of the colleagues, I think this is such a fascinating paper. We could probably extend this conversation for a bit longer here. And I know that this may not be feasible for some of the colleagues who probably have to go at 5, but the recording will be available afterwards for those colleagues who cannot listen at the moment. But it would be great, and I think with the permission of the colleagues, which I would like to request. So we probably could extend this by.
There's only 4.
Yeah.
I can quickly answer them because they are.
And also, I would like to hear from Michael as well, if that's possible. If we could extend it by 15 or 20 minutes, would that cause problems for you, Alex, and Michael?
No, not for me. I'd be delighted to do that. I'm sorry I took too long.
No, but this is a fascinating paper. So, we will actually would not like to interrupt your flow, but I think it's such a wonderful thing, and it's recorded, it can be actually people can still watch it afterwards as well.
Yes.
So I'll hand you back to Tianren. Perhaps you could then conduct the kind of a discussion plus the questions in a normal way.
Thanks, Dave. So in this case, could will first give his comments on the comprehensive studies from Alexander, and then we will pick all the questions from the audience. There are 4 in total currently, but for the audience, please feel free to type in more questions in the Q&A box, and we can extend the session a bit longer to accommodate these changes. Michael, I will hand over to you.
Okay, thank you. I will be short. Yeah, I am a great, let's say, admirer of Relutran. I understand, Alex, you started working on it in the 1980s. Is that correct?
Well, not Relutran itself. I mean, Relutran was baptized in 2007. And before that, I was working what I would call partial equilibrium versions.
Okay.
In other words, those things were integrated into Relutran as I made it general equilibrium, but yes.
Anyway, I greatly always respected your work, and the Paris model you presented to us certainly is one of the most comprehensive models, including residential location, workplace location, housing type and size, labor supply, non-work trips and work trips, and in the transport part, mode choice and such things. Yeah, and that, of course, is what I, as a modeler, am really interested in, the comprehensiveness of really talking about most aspects of urban life. And to my knowledge, your model is the only one which includes taxes. Is that correct? At least the...
Well, as far as I know, the theoretical models that I described, some of them include taxes, like Venables includes an income tax. But in his case, when you do an improvement in when you improve transportation, so it doesn't have congestion, but you can improve transportation by just assuming that, you know, the cost per distance goes down, then his income tax revenue goes up. And the reason is, even though he has a TFP externality, he's not taking into account that the TFP externality can reduce the price of the product.
At least I don't
Now,
know.
this would be correct, and it is correct in his case, because he's assuming that the product is traded in the world market, right? So then the price is then fixed implicitly fixed. But
okay,
so it's not true that some of them have income tax, like Perry and Bento have an income tax as well. So it's not true that all models, but all models of this level of realism, you know, with lots of zones, you know, the type of models that we all work with, which I would say this is a Luti model of some kind, right? I believe that may be the first one. I'm not sure. I cannot say 100%, but I think so.
Okay, at least I know only models which do not really treat taxes in detail. The model is of the type of the production function as I classified models earlier, with the assumed impacts of the Grand Paris project, that the productivity rises, real wages rise, consumer utility rises, and near the mega project there is also an increase in jobs and population, which of course means that rents rise and in migration increases. The model output is more, let's say, controversial. So I'm not really a friend of the assumption there. Of course, I realize that the total factor productivity is one of the major objectives, but I find it also fascinating how you really discuss the conflicts which are related to productivity or TFP, because higher TFP makes workers more productive, which means less workers are needed and some are dismissed. Higher TFP lowers costs and price, so more jobs are created, and higher in-migration increases the TFP So there is a positive feedback, but also a negative feedback with respect to the available funds are distributed over a larger number of people. I also liked your welfare analysis and social benefit analysis, which are really interesting. I did not really like how you treated congestion pricing. Of course, they are negative in the sense that they reduce the household income, but on the other hand, they have a great advantage with respect to, let's say, environmental quality, and I will come to that in a second. Sorry?
Yes, I agree. Yeah,
okay.
I agree.
I understood the no. Yeah. Now I will, to be quick, close with 3 questions. And the first of that is, why do you really insist on equilibrium? Everybody knows, and I have spent lots of papers and time on discussing that, because we know that cities are never in equilibrium. Do you have a quick answer?
Yes, I knew you were going to ask me this question, so I actually couldn't sleep last night thinking you're going to ask me. No, I'm joking, but it is a good question, but it's a, it's an age-old question. What kind of model should we use, right? So I guess I do equilibrium model because I cannot do a dynamic model as well as I would like. That is my simple answer, which means that there's all kinds of difficulties with data. There's problems with all those kinds of things. It's just easier. And I don't see the model as a tool of predicting what will happen, what will actually happen. I see the model as a tool for understanding certain effects that are not easy to figure out otherwise, right? Both qualitative and quantitative. So an equilibrium model is the simplest way to do it. I mean, I will never say that I should not do a dynamic model if I could do it. But I want to do it really well, consistent with economic theory and that sort of thing. Now, I'm not denigrating dynamic modeling because it cannot be done well, but it's true that the data requirements are much heavier if you do a dynamic model. You need to have data from several points in time. You need to know how things change over time. Everything is just much more complicated. So I have done some dynamic modeling, but it was a relatively simple form, right? I mean, I've done in the Chicago applications of ReloTrend, for example, I looked at every 10 years. So starting with the year 2000, 2010, 2020, 2030, where this was done in approximately 2013, 14. So I was assuming about 20 and 30. I didn't know what would be the exogenous inputs, right? So that kind of dynamics, but this was actually a sequence of static models. It was not truly dynamic, right? I apologize. I don't have a good excuse.
No, we don't have the time today.
I'm not that good.
Just that because we need longer time. But more important probably is my question: why you didn't include any environmental variables or outputs?
But actually I do, because the model does produce gasoline consumption by vehicles. And that data is easy to get. So actually predict, if you look carefully at one of the tables, I forget the number of the table, it's 6, 7, or 8. You see that this project reduced gasoline consumption by 7.5%.
Yes, but there are, of course, other environmental impacts. And I think most large railway projects in the world are very much based on arguments regarding environmental effects. And at least in your presentation, you didn't mention it.
I couldn't model the other things. For example, I don't have data to be able to model whether industry would become less polluting because of this project. Now, that would be a very indirect effect, except that to run all those trains, you need to produce electricity. So maybe to produce that electricity could have adverse environmental effects, although we know France is very heavy nuclear power, which is very clean. So, I mean, so a lot of the reasons I couldn't do those things is because of data limitations.
Okay. Again, by mentioning nuclear power, you open up a new, let's say, maybe a very long time of discussion. Yeah. My last question, and I'm try to be short, is again the last question I asked Geoffrey, and that is our webinar series is called Modeling the New Urban World. Could you kindly reflect on the likely impacts of the post-COVID city on the success of the Grand Paris project?
Okay, so yes, and you and I talked about this in some of the previous presentations in this conference, right, during the informal discussions or what have you. So when I started doing this, there was no pandemic, and I haven't done anything about the pandemic in the model. Again, you know, I don't know how to deal with that, but I know conceptually that if the pandemic were to last forever, which I don't expect, and since you and I talked about it, we had news about vaccine coming hopefully very soon. So unless it's a terrible vaccine, kill more people than the pandemic itself, I don't want to even think about that possibility. Then all the effects of the pandemic should be transient. If not, public transit will have a disadvantage because you have less social distancing in public transit. And so I'm aware of that, yes, but I didn't do anything about the pandemic.
Okay, Tianren, because of the lack of time, I stop my questions here, even though I would feel like discussing those things with Alex for hours. But this is unfortunately not possible, so I turn it back to you as chair.
Thank you, and I'm now taking over the chair because Tianren just told me, and in fact reminded me, because I knew this, that there is the North American Regional Sciences Association conference that Jeff and Tianren will need to attend. Therefore, he's left. He will come back later, and Jeff will as well. So, and both of them send their apologies. Meanwhile, thank you so much, Michael, for the questions. And yes, because of the future, I suppose that it is still going to be important to look at equilibrium and spatial equilibrium. So this is a topic that we're going to need many more hours yet. And Alex, if you would have time, I would like to perhaps talk through these questions with you that colleagues have. I think the colleagues, lots of colleagues that are still remaining online. So there's one question.
Yeah.
Sorry, go on.
I can read the questions if you want, or you can read them, whichever.
Yes. Well, there's one question about agglomeration effects, and the two questions about the congestion pricing. And yes, because if you have already read the question, maybe you could start to address them. That would be fine.
Yeah. So the first question is from Mingfei Ma. It says, does the agglomeration effect vary by industry in the Paris model? It's a very good question. So in the Los Angeles model, which is recently published in Transportation Research B, where we look at different things, we don't look at the same things at all. There are 9 industries. This is using American data, which is quite easily available for any big metropolitan area. In the case of Paris, it wasn't possible to get data by industry. I mean, you could get some data by industry, but then you don't have wages, or you don't have this, you don't have that, so it's not possible. So there is no industry disaggregation. There's only 2 industries, private sector, public sector, on the basis of employment. And in the model, it is assumed that both of them have agglomeration effect. We have it in mind to do some simulations where only the private sector has agglomeration effects, for example. And yes, it would be very important to have different industries. For example, have a high-tech industry where the agglomeration, the Marshallian effect should be much stronger. But on the other hand, all these empirical works that I mentioned, there's more than 50 studies that are really summarized very well in an excellent paper by Gibbons and Graham that was published in Economics of Transportation earlier this year, no, last year in 2019. None of those studies are doing it by industry as far as I know. So yes, it is very important to calculate those alpha and beta coefficients by industry. But to really calculate those, we need much better data. We don't really seem to have it, or maybe there is, but no one has really done that. So that's my answer to that. The second one is from Marshall Shanik. Please describe the congestion charge. Is it on all roads? Is it variable or a fixed charge per distance? So this is a very good question also. I know Marshall told me in a private email he has to go to a meeting, so he's probably not in the audience right now. But the answer is yes. We have a road network of 3,000 links, and we use congestion charge on every one of those. So you should think of these links as aggregations of the underlying actual road network. So in any model with zones and network, you're dealing with an aggregated network. So we calculate a congestion charge on each link, at all the roads, in other words. And is it variable or fixed? So we calculate the congestion toll as the difference between the social marginal cost and the private average cost of travel, which is how it should be calculated in theory. Yes, so there's other ways of doing it. You could have a distance charge, or you could have a cordon toll, something I've looked at in Chicago using the Relitran model, and that's a published paper. Yes, these are usually thought of as sort of less complete ways of treating congestion, right? They should produce lower welfare than what we're doing here, but not necessarily if you also have another externality, which we do have in this model. Okay, so the answer is I haven't done that. I've only done sort of the most basic thing I could do, which is that is a congestion toll on every road, and it's a difference between the social marginal cost and the private average cost. The third question is from Francisco Javier Martinez Concha. Where do the rents go? Do they feed back into households' income? If not, is it possible that the flow of wealth into high-income landowners and its special concentration may be underestimated? Other possible not accounted effects. Okay, this is also a very good question. So the rents in the model, so in the model it's assumed that all the consumers of housing are renters, there are no owners. Okay, again, this is primarily because of data limitations. Although we know how many people own, how many people rent, still it's not easy to model this. It would require a more sophisticated model. So the rents are just aggregated and considered as a part of welfare. They are not recycled back into the economy. Okay. Some of the rents would be collected by people who live outside the region. Some of the rents would be, recycled back into the economy into the hands of landowners, etc. But that is not included in the present version. And then there is a question by Geoffrey Caruso.
Yes.
Technical question: how is the congestion price computed? Is it optimized? If so, how given welfare is computed exposed? So it's computed like I said in answer to Martial's question. It's just computed as the externality, which is on every road, which is the difference between social marginal cost and private average cost. It is not optimized. If so, how given welfare is computed ex post? So welfare, as I said, is the sum of different things like a compensating variation of the consumer, which includes all the effects of the changes in wages, rents, travel times, congestion tolls, everything, right, from utility. Because compensating variation is just a monetary measure of utility. And then aggregate rent changes, they are not recycled back, as I said in answer to the previous question. Tax revenues, and including congestion toll revenues, if any. In the paper in Transportation Research Fee, which is for Los Angeles, we actually look at the potential benefits of recycling congestion toll revenue. So we do the same thing as in this paper. We tax all the roads in the same way I described, but we take the congestion toll revenue and we say, now, since we have this revenue we didn't have before, can we reduce the revenue from the income tax or the sales tax or the property tax so that the total revenue, including congestion tolls, is the same as before? Now that's beneficial because the congestion toll is a good tax. Why is it a good tax? Because it's fixing an externality, which is a negative externality. So if you take that revenue and reduce the revenue from a bad tax, by bad tax I mean a distorting tax, income tax, sales tax, then you get a big boost in welfare, and that's what that paper is showing. That the consumer benefits go up 3 times, roughly, if the congestion toll revenue is recycled back into the economy. In this paper, we're not doing that. We have the beginnings of another paper where we're going to look at property tax, not property, sorry, tax reform in the Paris region, which is very counterfactual. But what we want to do in this paper is say, suppose we got rid of all the income tax and sales tax, and instead we had just a property tax and a congestion tax. So the property tax is nearly neutral, which means it is very little distorting, almost no distortion. I don't want to go into the theory on this, but it has to do with Henry George theorem. And the congestion toll, as I said before, it's fixing a negative externality, so it's a good tax. So if you do that, we already have some simulations, but they are not properly done yet. It's just a rough kind of exploration. Then the benefit cost ratios go much higher. Okay, but that is not coming, that would not be a surprise to economists, but they really go up a lot. But that's another issue. We haven't done that yet. So those are all the questions that I see here.
Thank you so much. And this is probably as many questions as we could accommodate in this session. So again, perhaps in organizing future sessions in the Applied Urban Modeling Conference, we'll actually hopefully to factor more time. As you can see, there's a lot of interest on the subject, and also encourage colleagues and particularly young students to read Alex's papers, where you could find a lot of inspiration indeed. And I think Jeff probably is still at the NASC session, and we probably should end here. But before that, what I should mention is that our student host, Yue, has already posted the meeting, posted for post-session talks on the chat box, and the colleagues actually can get from that and then log on in the next few minutes. But before I go, what I have found today was that an interesting fact that as the sessions gets into the equations bit, the audience numbers on this social platform broadcasting not only stay firm, and in fact the numbers has seen. So in fact, I think we're also attracting younger students who are probably using these social platforms more. So clearly there's a huge amount of interest at the moment. So, and I'll just check with Alex and Michael. Any final words before we finish? Alex?
Well, thanks to everyone
and
for
Michael?
listening all this time, and for the excellent questions. And Michael, thanks for your comments.
Yeah, well, this is an extraordinary session. Even for me, I really learned a huge amount. Actually, this is a very long session. Thank you so much, Alex, for doing it. And Michael?
He's muted.
Michael, you're muted. So, yeah.
Here we are. I can only repeat
Yeah.
what I said already earlier, that I'm full of respect and admiration for Alex's achievement over so many years. Thank you very much, Alex.
Well, thanks for your comments. I really enjoyed your comments and everyone else's comments. They were very good. So
yeah.
Hopefully
Well, you
we'll
can see that
have something better to present, and maybe I'll live long enough to do a dynamic model. I'm trying to stay healthy.
Oh, well, because absolutely, to combine dynamics and equilibrium would be actually one of those streams that the models might have.
Well,
now, welcome back, Jeff.
Model,
And
I do mean dynamic equilibrium model. I think that should be done before I do a dynamic disequilibrium model. So there is something called dynamic equilibrium.
all right, yeah. Well, it just sounds like a very good session that could organize in the future events, right? So to talk about that. And Jeff, Jeff, welcome back, and thank you so much. And any final words from you to the audience?
Or just thank you. I got a couple of excellent questions, and thank you, Michael, again for taking the time to make such good comments. Thank you.
Yeah, and again, there actually, I myself actually have noted so many points that I would like to myself to read and my students to read as well on that. So Jeff, thank you so much. So now, this is a great session. We are already on extended time. So what I like to do is to close this session now and then move on to the after session talks on the second email all the colleagues who participate will have received. And also this is in the Zoom chat box for anyone who would like to log on. And then I'll start that session in the next minute or two. And once you have had a short break, and you're welcome back. And I look forward to seeing you there. And with thanks to the student host, actually, who actually faithfully done the whole session, and it's for a very smooth hosting, and also Louise and Jamil actually for co-hosting it. Thank you. And maybe you should press that red button, and then we'll end this session. So we'll see you on the other side in the post-session talks.
See you. I have to go to the bathroom. Bye-bye.
See you. Bye.
Yeah, well, yeah.